Welcome to homework.
In this question, we are presented with a relation defined on a set of all polynomials, with the relation saying that polynomial f and g are related if their nth derivative are equals, where n is some positive integer. So n derivative, you just take derivative n times on the function. All right. First, we have to show that the relation defined like this is equivalent. So we check three properties, right? First, is easy to see that any function n derivative will equal to itself n derivative, right? So any function f relate to itself. And symmetric, so if f n derivative of f equal to n derivative of g, then we also have the other way, n derivative of g equal n derivative of f, which means g related to f. And transitivity, I will not write the equation. If we have f related to g and g related to h maybe, then we must also have f related to h. Why? Because n derivative of f will equal n derivative of g, which equals n derivative of h. So f and h, like their derivatives are equal. So these are easy to see. Once we check the three property, then R is equivalent relation. Next, if it's equivalent relation, then we will be able to find equivalent class for each element. Now we are asked to find the class for this particular function x to the 4. So first, x fourth derivative of, not fourth, sorry, n is 3, so we find the third derivative, right? The third derivative of x to the 4 is 24x. So any function g, if g gonna be related to f, or that is to say g is in this equivalent class, it means that the third derivative of g must also equal to 24x, right? And what kind of polynomial can have the derivative like this? Well, g would be of the form x to the 4 plus something x squared, something x, and something x to the 0. These ABC can be any real number because they're gonna disappear under third derivative anyway. Why don't we have x cubed term here? Well, because if there is something times x cubed, suppose call it d, we're gonna be left with 6 times d, like add to the 24x. So we cannot have that. And what about the term larger than x to the 4, x to the 5 maybe? Well, we're gonna be left with something times x squared, if we derivative 3 times, right? And we don't want that either, so it has to be of this form. Now let's write it. So we will call the class A. So this equivalent class will be a set of function in real number such that they have the form x to the 4 plus ax squared plus bx plus c, where a, b, c are some real numbers. All right, this is a equivalent class of x to the 4. And you can see that x to the 4 is also in this form, but a, b, c are all 0. Okay? And that is how you find the equivalent class. That is it for this video. Thank you.